Imagine this, every single person on Earth, all 8 billion of us, standing together, waiting for a countdown. 3, 2, 1, jump. Would the Earth move? Would giant earthquakes shake the planet? Could we change Earth's orbit? Or would absolutely nothing happen? Today we are answering one of the internet's favorite science questions. What would happen if everyone on Earth jumped at once? The answer is not just nothing. Physics does say something happens. It is just so tiny on a planetary scale, and so messy on a human scale that the real story is much stranger than the question sounds. Let's start with the math. The average person weighs roughly 62 kilograms, or about 137 pounds. Multiply that by 8 billion people, and together humanity weighs about 500 billion kilograms. That sounds enormous. It is heavier than many mountains. It is more mass than any crowd, city, or stadium could ever make you feel in your bones. So it is tempting to imagine all that weight slamming down and making the planet lurch. But mass only matters when you compare it to something else. And the thing we are comparing it to is Earth. That comparison is where the idea starts to fall apart. Earth weighs approximately 5.97 sextillion kilograms. That is a 5, followed by 21 more digits. It is a number so large that ordinary intuition does not handle it very well. Compared to Earth's mass, every human being combined is almost nothing. Imagine placing a tiny grain of sand on top of a giant mountain. That is the kind of comparison we are dealing with. Even if every person jumped at the same moment, Earth would barely notice. But barely is not the same as not at all. Something interesting would still happen because the laws of motion do not ignore tiny effects. They just make us calculate how tiny those effects really are. According to physics, every action has an equal and opposite reaction. When you jump upward, you push downward on Earth. That means Earth actually moves slightly in the opposite direction. Yes, the entire planet moves, but before you get excited, the distance is unbelievably tiny. Because Earth is so massive, the jump from all humanity would shift the planet by less than the width of a single atom. That is smaller than anything your eyes could ever see. Smaller than dust, smaller than a cell, smaller than the wavelength of visible light. And the moment everyone landed, Earth would move right back. In other words, the effect is real. It follows Newton's laws perfectly. But for the planet as a whole, it is practically zero. Many people think 8 billion people landing at the same time would create a giant earthquake. It sounds reasonable. A huge impact should make a huge shake, right? But the answer is no. Earthquakes release enormous amounts of energy stored deep underground, usually from tectonic plates slipping after stress builds for years, decades, or centuries. The energy produced by humans jumping is tiny compared with natural geological forces. Even large concerts, sports stadiums, and festivals only create small vibrations. Seismometers can sometimes detect them, but that does not make them earthquakes in the destructive sense. Even if every person jumped perfectly together, Earth would not suddenly crack open. The planet experiences far stronger forces every single day, from ocean tides, storms, impacts of waves, and the constant movement of rock beneath our feet. There is actually a much bigger problem than moving Earth. Getting everyone together. People live across every continent, in different countries, time zones, mountains, islands, cities, forests, deserts, and polar research stations. Some people are awake while others are sleeping. Some are babies. Some are in hospitals. Some are on ships, planes, and trains. Coordinating 8 billion people would be almost impossible. But let's pretend we somehow succeeded. Imagine every person on Earth travels to one giant area and waits for the same countdown. Now the question changes. We are not asking whether Earth as a planet is in danger. We are asking what happens to the place where everyone lands. How much space would humanity need? Surprisingly little. If every person stood shoulder to shoulder, the entire human population could fit inside a large city-sized region. That sounds impossible because we are used to seeing people spread across the whole planet. But humans are small compared with continents. Now imagine 8 billion people jumping and landing together in the same place. The local ground would experience a huge shockwave. Nearby buildings could shake. Structures might be damaged. People could be injured. Not because Earth is moving through space, because the crowd itself would create an enormous impact in one concentrated location. The local area would suffer, the planet would not. What if we somehow used all that jumping energy to push Earth? Could humanity move the planet? Could we shift Earth's orbit around the Sun? The answer is no, not even close. Earth is already traveling through space at about 30 kilometers per second as it orbits the Sun. The tiny force generated by human jumping is insignificant compared with the enormous gravitational forces controlling our planet. And because the jump begins and ends on Earth, most of the motion cancels out inside the Earth-human system. No matter how hard humanity jumped, Earth's orbit would remain unchanged. The Sun would not notice. The Moon would not notice. Your calendar would not notice. What if everyone jumped repeatedly, day after day, year after year? Could the effects add up? Still no. Each jump would mostly cancel itself out when people landed. The energy involved is simply too small, and it stays inside the same Earth-human system unless something leaves Earth entirely. If humanity wanted to change Earth's motion, jumping is the wrong tool. Rockets can change motion because they throw mass away at high speed. Jumping only pushes against the planet we are still standing on. Humanity could jump forever and never meaningfully change Earth's path. Physics wins again. So what would happen if everyone on Earth jumped at once? Earth would move slightly, but by less than the width of an atom. There would be no giant earthquake, no change in Earth's orbit, no planetary disaster. The biggest effects would happen locally where people landed. The real lesson is just how enormous our planet truly is. Even all 8 billion humans combined are tiny compared with the world beneath our feet. And that is pretty incredible. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and join us for more fascinating science questions. See you in the next video.